Hi everyone, in this video I'm going to go over sinusoidal functions. This is how we graph real-life applications of trig functions. So the definition of a sinusoidal function is basically how sine and cosine curves are jointly the same curve. They have pretty much the same form. You can have cosine or sine. The generic one has sine, but you can also make this cos if you'd like. A is your amplitude, B is your frequency, C is your horizontal shift, and D is your vertical shift. Now also remember that D also gives you your midline, which is the halfway point of the graph between the maximum and the minimum. Okay, so there are a few steps to follow when you're graphing a sinusoidal curve. Usually it's a word problem, and you have to create the correct window to make this word problem. So sometimes they'll give you an interval, and then you'll use the interval they'll give. So like say they say graph between 0 and 12. If they said that, this would be your x min, and this would be your x max. But sometimes they don't tell you that, and that's majority of the time. So when their interval is not given, we usually make the x min 0, and we make the x max whatever 2 pi over b is, which is our period. And that's how long one complete cycle will take. So this is really important that we have the x max as our period, because we want to see one full cosine curve or one full sine curve, depending on what we're graphing. Now the maximum and the minimum for the y min and y max all depends on height. And height of a cosine and sine curve is based off of the midline and the amplitude. So say I had a midline of 10 and an amplitude of 5. My maximum would happen at 15 and my minimum would happen at 5, because I'm adding 5 and then subtracting 5 from 10. And that's what this formula is right here. So in order to graph your sinusoidal curves, you want to first make sure you can create a proper window to see the full picture. If you forget these steps, remember, just trial and error to try to get the best picture possible of the sine or cosine curve. So I pulled a few examples from your lessons. I don't know really which one came from, but basically these questions will go over what we just talked about in the first slide. So this question says, in a certain ecological system, the population of owls tends to vary periodically over time. The population of owls 0 can be represented by this function. Now I always like to label what I see. So I see that there is an A value here. This is my frequency B, and this is my D value, my midline. So those are my important key facts right now. And they also tell you the time frame, years since January 1st, 2001. So they don't tell me an interval of where to graph this from, so I'm going to make my x min 0. I'm going to make x max my period. So to find my period, I'm going to do 2 pi over b. Now the b value we have is pi over 10. You can type this all into your calculator at once, or you can do keep, change, and flip. And you'll get the pi's to cancel out, and you'll get 20. Okay, and then your y min is going to be whatever d minus a is and d plus a is. So if I do d, which is 150, minus a, which is 30, I will end up getting a minimum of 120. If I do d plus a, 150 plus 30, I will get a maximum of 180. Now I'm going to talk about the scaling in a second, but first I'm just going to box this off so you guys can kind of see this very important fact. Okay, now as you know, sine and cosine are very symmetrical, and they have pretty much 5 key points to it. So if I was to create a sketch, I know that I have a sine curve. Sine curve looks like this. I know that it's going from 0 to 20 because that is my x min and x max because of my period. Halfway will be 10, half of that will be 5, and half of that will be 15. This is how you could probably scale the x. So the trick would be to take the period, which is 20, and divide it by 4, which will get you 5. And this tells you to count by 5s in order to get the proper points that you would need to plot the sine curve. So I changed my window over here in my calculator, and then I put it into y equals, if you can see, and then I was able to create my graph when I graphed it. So then I go ahead and I can see my calculator graph, and here's my graph right here. I can look at my table, and since we divided 20 by 4, we know that steps of 5 will allow us to see the key points. So if you notice, 0 is at 150, which is a nice point. We got 5, which is another nice point. And if you notice, these are our maximums, our midlines, our minimums. Our next one would be this guy here, 150. And then we also have 120, which is our minimum. And then 20, which is our maximum. Oh no, midline again. So using this, you can actually create, you can create a nice sketch using this table. So what I mean is that you can now see, this is from 0 to 20, just like I created my sketch before. There is a midline at 150, because we know that's our midline from our equation. It was the D value. Remember, the D value right here, the thing being added, that is our midline. Okay, we also know that our maximum was 180 and our minimum was 120. And then I can get my points from my table. This was at 0, 150. This was at 5, 10, 15. 5 was at 180, 10 was at 150, then back to my minimum and to my midline again, and there is my nice sine curve. So let's answer some questions they give us. They ask us, find the maximum number of owls. Well, that's just here. This is our maximum right here, and the max is 180 owls. So that would be 180 to that question. And after how many years does this occur? It occurs after 5 years, because that's our X value. This is the years, and this is the owls. So these questions are very real life applications, because we are allowing us to see, so 5 years, 5 and 180 owls. So this allows us to see things that create trends sinusoidally or cyclically. So like obviously there'd be a lot of owls, then people die off, and then lower owls, and so on and so forth. Also, time of year will impact when the owls are high and when the owls are low. So this is why this is so important. So this is another example of selling quick ice, which follows this model right here. Where T0 represents the beginning of January and T equals 12, the end of December. Actually, there's probably a typo here. We should probably put an F here because there's no function name. It's just T. So it should be F of T, but that's besides the point. Okay, so first off, we need to make our window. So they don't tell us the proper window, but you can kind of guess, because we know from the first slide you always want to try to make your x-min 0, and then I'm using 12 because T equals 12 is the end of December. But again, we can get this from our B value. So let's analyze the equation. This is your A, this is your B. Now it's weird because they put it with the pi over 6. This is your C, which is your phase shift, and this guy here is your D. So if you guys can really look in here, they try to mess with us with this one because of the fraction. So you can see the A is right next to the cosine. You can see the D because it's added to the side. Remember, this is our midline right here. This is our B, and then our C is the phase shift. The B is a little weird too, because the B is the thing being multiplied in front of this parenthesis right there. So make sure you know it's pi over 6. But again, I'm trying to prove to you why I use 12. So if you do period, which is 2 pi over B, the B value is pi over 6. This will multiply into 12. So that's why my X max is 12. My Y max, my Y min and my Y max, remember I did the formulas. So the formulas are D minus A and D plus A. Oh, I wrote an 8. That's weird. Okay, D plus A. All right, so D minus A is just 7,500 minus 7,500. So that's why we have 0 there. And then D plus A would be 7,500 plus 7,500 and that's why my y max is 1500. Now the reason why I scaled the y scale by 3750 is because I know that there's going to be, what kind of curve is this? I think this is a cosine curve. Well, for any type of curve, you'll need a max, a middle, a min, and a middle, and a max. So I know there's 1, 2, 3, 4 key points. These guys are the same, the one over here and here. So if you divide the maximum 1500 by 4, you actually end up getting 3750. And I'm just going to double check that on my calculator, but I'm pretty confident. 15000 divided by 4. Yeah. Okay, so that's what I chose to scale by. That also allows me to see the table well. So I put this into my y equals just like so, and now I'm able to create myself a nice graph. And when I press graph, I start to see this nice curve that's occurring right now. And I can look at my table, and I can see my key points here. So I'm going to look for the ones that are nice. So like my minimums, my maximums, all that good stuff. So you can see that this guy here, here's my max. Here's that 3750 I was talking about. This also looks like a nice number. This is also a nice number. So those are all the ones you kind of want to plot, and they will help you create a nice curve. So let's start to make our XY scale. So I can actually count this straight by ones. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I want to, on my y-axis, I want to put my midline for sure, and that's going to happen halfway up. So 1, 2, 3, 4, midline. I put it as a dashed line because it allows me to see it better when I'm trying to plot points. So this is 7500 because that's our midline from the formula. Remember, that was the D value. My maximum happens at 15000, and then my minimum happens at 0, which is already plotted. Okay, and then I also counted by 3750, and you know, you can actually split 7,500. If you divide that by 2, gets you 3750. Oh, let me just write that a little bit neater. 3750, which means if you add 3750 and 7,500, you can get this point here, 11,250. And if you notice, those are the key points that I kind of like, circled on here on our table. So if you can kind of see, 1,500, 11,250s there, 3750s there, and I can use these points to make myself have a nice graph. So I'm going to go to my table and I'm going to graph. Obviously this is too small, so you guys will have your calculators on the side right now looking at your table hopefully, and then I'll plot these points. So I'm going to plot. This is my first point, 0 is at this value, 2 is at my maximum, and then 4 goes back to this value, and then 5 goes to the midline, and then 6 goes to 3750, 8 goes to 0, 10 goes to 3750, 11 goes to the midline, and then 12 goes back here, and boom, 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 there is our nice curve. And they also ask us a question. They ask you, in what month are the most quick ice sold? Well, that happens right here. It's in month 2. So if we know that T equals 12 signifies the end of December, then month 2 would signify the end of February. Okay, the last question I'm going to do in this video is a homework question. It gives you an equation based off of the tides going in and out on a beach. Now, this is actually a perfect application of a sinusoidal function because it represents a cyclic function of high tide, low tide, which is a repeating pattern. The first thing that they ask is they ask you to find your period. So remember, our formula for period is 2 pi over b. This is a This is B and this is D. Remember, B is always next to the X, the A is always in front of the cosine, and then the D is always being added to the end. So if I do 2 pi over 6, I can type that whole thing into my calculator and get 12, which makes sense because every 12 hours you guys should have some sort of tide change. The amplitude of this equation is 0.75 feet. Also, I want to label this hours. It's also important to label these things in context, so please label. High tide and low tide. Well, we can find high tide and low tide by finding our Y min and our Y max. So if we use the formulas D plus A, so 1.5 and D minus A. So I would do 1.5 minus 0.75 and 1.5 plus 0.75 to get my Y min and my Y max. So when I do that, I get 2.25 as my max, and then 0.75 as my min. Okay, so now it says how many hours between high tide and low tide. Well, it would be really great to visualize this on a graph. So I'm going to change my window to the things we just talked about, 0, 12, Y min, Y max. And then you can see my graph here, and you guys can kind of see the high tide is here and low tide is here. And they ask me how many hours between. Well, if this is 0 and this is 12, then this is 6. So how many hours between high tide and low tide? It would be 6 hours. So I'm going to put 6 hours here. And then it says, how deep will the water be 3 hours after high tide? Well, that will be about here. And because it's split nice in half, that has to be at my midline. But again, you guys can look at your table and you'll see at 3, you should see 1.5. So 1.5 feet, which is kind of that's the average. This should be the average water level. Remember, the midline always represents your average of whatever the scenario is. And the last question they ask you, to the nearest tenth of an hour, name what time the water will be 1 foot deep. So what I did was I put in my equation into Y1 and I put into Y2 1. And if you can see, this is the line that the graph popped up, and I can see where the graphs would intersect. It would intersect here and it would intersect here. And using the intersection command on the calculator, you can have 4.4 when it's 1 foot deep hours, and also 7.6 hours. So I hope this video helped you guys on sinusoidal functions. I'll see you soon.